Hello guys, welcome to another session of Mate Math. I hope you guys are doing good. Yeah, I'm also doing fine. Yeah, I'm also doing good. Yeah, yeah, yeah. All right. Do you guys remember this video or this question? Somewhere last year we solved this question. This one versus this. Yeah, it was a very long video, some about more than more than yeah. Do you guys remember that video? Yeah. We look at this one. I mean, it was all solutions. We look at this one, whatever that we have to do in order to get answer for this one, and we compared it with this one also. I mean, just to find out how the difference, square root and the cube root, the difference when you are integrating them. I mean, what are the difference? Do they require the same approach or something else? I mean, in that video we were able to find out everything, right? I hope most of you do remember this particular question. Yeah. I hope so. But the question is, are we going to integrate it again? Did we have our answer wrong? So why are we seeing this? It was last year, not this year. So why are we seeing this? Come on, what are we gonna do? Well, you remember in that particular video, while we were working out the solution, I told you that because of the nature of the workings, or because of the some complex approach or some unique approach that we use, I mean some unique ways or methods that we use in order to get answers for these questions. Remember in that video I did promise you that I would do my possible best to give you the derivative of what? The integral of this one, the answer to this integral. Remember in that video I said I promise you I will differentiate the answer that we will get to this one. And you remember some days, or maybe let me say some days or some weeks or some months later, I did honor the promise by releasing or uploading or giving you the answer we had to this problem. Yeah, I remember we had that one. If you don't remember, you just check your videos and one of the lessons that we had. I think you remember. If you don't remember, don't worry, because it's been a while. It's been a very long time. I'll also try and leave a link to this particular video in the comment section, so that if you missed it or if you didn't get the chance to watch it, but you are hearing something about it in this video, then you just go click on it and then enjoy yourself with it. But let me just give you something small about it. It's very long, about more than an hour ago, but at least the list is 1 hour. The list is 1 hour, but it's no more than 5 hours going. I think it's at most maybe 4 hours. Yeah, sir. Sometimes it's very long. So you just, if you want to enjoy, just find time and then watch that video. Yeah, we did a whole lot of workings. It wasn't easy. We applied some methods, various, and a lot of things to just get individual answers for each and every one of these. Yeah. So last year I honored the promise I made in that particular video, that I'll give you the derivative of the answer that we had to this one, and I did upload that one. All right, good. I'm not going to say the answer because the video is there, and I'll leave it in the comment section. And after this one, in that same video, I also said that this one, integral of cube root of tangent x, because of the nature of the cubes, because how the cubes are, I did not promise you that I will give you what the derivative of this, the answer to this was integral. But I said I'm not promising you, but when you get it, fine. If you don't get it, fine. That is what I said in that video. Don't worry, when you click on the link and you are watching it, when you reach this part, you hear what I just said. Let me repeat. Like I said, as for this one, I'm not promising you, but when you get it, you get it. But if you don't get it, you see the reason. Yeah, because the cubes, I said the cubes are all something else. But if you want to try, you do it on your own. But if you are doing it and you get stuck and you reach out, I'll just sort you out. But just to promise you, as I did to this one, that I'm just going to give the derivative of the integral of cube root of tangent x in that particular year. I didn't remember saying something like that, but what I did remember was I will not promise you that I'll give you the derivative of the integral of cube root of tangent x, but when you get it, you get it. But if you don't get it, you see, I didn't make any promise, but what I promised, I did and did it. And this video and that one, they are all there. I remember when you go through your lessons, you will see that we have solutions to the derivative of this, and also solution to the integral of this, and also the integral of this. But the derivative of this one, integral of the answer to the integral of this one is not there. That one we didn't look at it. All right, so the question is, why are we seeing this? Did we make mistake in any of the videos? Are we going back to correct ourselves, or what? Well, the answer is, that year I didn't give you the derivative of the integral of cube root of tangent x. So in this video, I'm just going to give you the derivative of integral of cube root of tangent x. Yes, I'm just going to give you that, and I'm serious about it. So here, no jokes. I'm very, very serious. I'm just going to give you that one. Someone may ask, why did it take you such a long time to give us that one? Why? Is it because you were busy, or is it because you didn't want to do it, or is it because you were lacking how to do it? Or maybe the question is, because I didn't promise. It's not a matter of, it's not like I wanted not to give you in that particular year in addition to this one, or because I didn't promise you, and because I was, maybe let's say, unwilling. Yeah, let me say I was reluctant to just give you the derivative of the answer to this integral. But for this one, I promised you, because I did made a promise to you guys. I have to find time and then give it to you by hook or crook. I have to find some means and then let you have the derivative of this one. But this one, because I didn't promise you, it was like, not maybe later, oh, tomorrow, maybe like this, it was, procrastinating, it was something like that. That it was something like that. It's not because I cannot work out, or because I've just gotten to know the solution, or gotten to know the way. No, that is not the answer. But it was because of didn't give you any promise that I'm just going to do differentiate the answer to this one and then let you have it, or walk you guys through in the in that particular in that particular year, which is last year. Yeah. So from what you were saying, then why are you going to do it today? Well, I think just not recently. Yeah, I was just assisting a certain person. Then he asked, yeah, I was just assisting, and then like there was some discussions, and then he said he saw this video, but he had the reverse of this one to this. The answer to this one, he had a reverse to that. But this one, the person didn't see. It wasn't a request for me to do that video, but well, the moment the guy just the moment he said something about this video, I mean the derivative of this, he just quickly drew my attention. Hey, in that video I said I will not give it to them, but it was like, oh, I'll be giving to them, I'll find time and do it, I'll find time and do it, I'll find time and do it, yeah, something like that. So the moment it drew my attention, and then I said, oh well, oh, these people, some of them might be looking for it to, I should have done it, I should have done it, procrastination, it's just a thief of time. So I said, oh well, let me find time and then walk them through, because it's been a while, because some of them, though nobody did ask me question about that one. Everything was clear in that video. Nobody did ask any question about that answer. So because I didn't have many questions, that is why maybe was that unwilling to do it. But yeah. So when he draw my attention, I started to let me do it, because it's been a while. So let me just do it, and then let you guys also have it. I know most of you might have forgotten the solution, but don't worry, I'll just write it, because that is what we are going to look at in this video. I hope you guys are okay, and I hope you guys are very clear on what and why we are going to do this video. All right, sure. So just get everything ready. This one too, the workings is something else, very is something else, and then whole lot of, but it's just fun. It's very simple. It's very simple as compared to this one. Very simple. All right, so without wasting much time, let's get into the video. All right, yeah, guys, do you remember in that video, as I said, I will leave a link to the description section for you guys. Okay, so in that video, this was the answer that we had to the integral of cube root of 4 tangent x. Yeah, that was the answer. So actually we are going to differentiate this, and remember, in most of our differentiation lessons, we've already done a lot about how to differentiate questions of this nature. I mean, where it is more than one, and there are a lot involved in each and every one of them. If you look at this one here, the natural log of this one, you have to first tackle this one, and here is the case raised to the power 4 to, yeah, something like that. We have already looked at something of this nature, how to deal with it. So this one is not it's not something new. The new thing here is how to deal with the cubes. Yeah, how to deal with the cubes. I know some of you, maybe I would say, were trying. The cubes was the only thing that might or that was giving you, some of you guys were trouble. Though I wasn't there when you guys were trying, but I'm just assuming that the one thing that will be giving you guys problem more than anyone who were trying to differentiate is the cubes, how to deal with them, especially when they are in denominator's position, how to rationalize is the problem. But you don't worry, you're going to find out everything in this video, and it's very simple. Yeah, it's simple, but not that simple. Why? Because if you said it's difficult, it will always be difficult. If you said it's simple and let your mind understand that it's simple, though it's a little bit difficult, but because you have trained the mind that it's simple, the mind is going to get it for you. All right, sure. Yeah, you really are just going to see a whole lot of things. So as usual, as we used to, we're not just going to use the chain rule or maybe the product rule, or maybe, yeah, we will use all of them but indirectly. I prefer using them indirectly. Yeah, so as usual we will tackle them one by one. We will first look at the whole of this as one, then we will look at this one as another one, and then this one as another one. After that we will combine our answers and then find out what we are going to get at the end of the day. But in all, the motive of working out this one is to get what? The cube root of what? Tangent x. So if you don't get that at the end of the day, you have wasted our time. Alright, good. So first, as you all know, we're just going to call this one so that we will not be mixing our answers anyhow. We will call this one A, and then the whole of this one B, and then the whole of this one as well C. So after differentiating A, move on to B, then we move on to C. Then the answer that we get for each of them, we will just go by the operation signs separating them. This here, the operation sign is here, plus. So we will just add A and B. After that, we will subtract C from them. Or you can also go by doing it A plus B minus C, provided you can deal with all of them at the same time. But if you can't, first either try and add A and B, later on you subtract C, or you can also subtract C from B or from A, and then whatever you had, you add it to this one or this. Alright, sure. So we are going to start with A, this one, that is 1/4 natural log into bracket the cube root of tangent x to the power 4 minus cube root of tangent x to the power 2 plus 1. That is what we are going to start with, and we are calling it A. Differentiation of what? Differentiation of what? A. Alright, so let's write our solution. Differentiating A. And remember, this is our A, this is our B, and this is our C. Now let me put down A for you. Already you are seeing it, this one as A, then this one as B, and then the other one as what? C. Good. Now this is our A. This is our A. You see, this one we didn't bring in the operation sign. You can, take the sign along, or you let it be as it is. Just pick the question, or just pick whatever you are going to integrate or differentiate. After that, you compute them by looking at how it was. I mean, by looking at this one. I mean, where the sign was what? Written. Here the sign is between A and B, and here the sign is between C and D. So if you don't carry it along, and then you get your answers for them and you are subtracting, here it will be A and then plus B, and then later you subtract C, or A plus B minus what? C. Then we will use it to compute our final answer. As I told you earlier, the rare case is going to be something else. The most scary part is this one, not the natural log. We all know the answer to the natural log of any variable, any variable at all. That is what? 1 over that variable. That is what? When you take derivative of any natural log of any variable, it will give you what? The 1 over that variable. But what is the derivative of natural log of the whole of this? You see, the chain rule. We have to apply the chain rule to solve it. But I'm not going to use the chain rule directly here. We are going to do substitution, and after that, you already know. Sure. So here, if I don't know. Well, if you want to differentiate the whole of this one as one, maybe you write 1 over if also sorry in the you remember when you were differentiating natural log absolute value of a particular variable. I showed you how I showed you everything, the steps involved in differentiating natural log. Why when you differentiate natural log you get 1 over a particular variable, and I told you that when it's not a single variable and it's doubled, you just assume that whatever variable that is there is just a single thing. So if it is a single thing, you just differentiate and then you write your answer as 1 over that single variable you assumed. But when you are writing that variable, instead of writing that variable, you just write what was originally there. In your head, you assume that the derivative of natural log of, let's say, y is, let's say, y minus p. We'll just give you 1 over y minus p, but somebody will find it difficult dealing with the y minus p. It might confuse that person. So just assume that y minus p is what? Maybe a single variable, let's say a. Even when it is like that, you know the answer is 1 over a. Yes, it's the same thing. Y minus p, the answer is just the same thing as what? Y minus a. But in this case, instead of writing the a, you just write y minus what? P, because you were not given a, but you are just assuming the y minus p is a, just to help you apply what you know better. In applying what you know better, you also got to be smart so that you don't get your answer wrong by just replacing what you assume the a for. Okay, so here, if you want to write your answer directly, just going to be first, using the chain rule, the derivative of the whole of this will be 1 over 4 times 1 over natural log of, let's assume this one is, let's say, x, so it will be 1 over x, and instead of writing the x in the denominator's position, I will write this one, and after that we multiply it by the derivative of what? The whole of this. Any question? If you have any question, do well to drop in the comment or section. Alright, so here, to make what I'm saying very simple, you're going to do what? Substitution. You're going to let we will let a variable be equal to this one, the whole of this, that is cube root of tangent x to the power 4 minus cube root of tangent x to the power 2 plus 1, the whole of this, so that the inside here will become what? A single variable, which will not confuse us and which will make it simple, as we all know, in terms of what? Differentiating natural log. Now let's continue. So we first going to set the whole of this one be equal to u. After that, we will let another variable be equal to this one. Alright, so as I said, we are going to let a variable be equal to this one. So we are going to let f be equal to this one. Here I'm not writing the whole of this one for you because it's very long, so I'm writing let f be equal to what is in the bracket. So what is in the bracket here? What is in the bracket here? The bracket here is what? This one. Okay, so f is equal to alright, so what is the derivative of this? Now when you are, I said this one, this is only thing that might be giving you a lot of problem, but we are going to find out how to do it. Now remember, square root of, let's say, y, the value of that square root is what? 1 over 2. That is to the power y to the power 1 over 2 is the same as what? Square root of what? Y. What about cube root? The value is what? This one here, but it's not 3. The value is not 3, but the value is what? 1 out of 3. 1 out of 3. So to differentiate this one, you have to consider the value of what? This cube root. The value is 1 out of 3, and here we are having another it is going to the exponent position, and the exponent position is already having what? 4 there. So it's going to be 1 out of 3 times 4, and that will give us what? 4 over 3. 4 over 3. As for this one, most of us already know how to do it, so I'm not going to write that one for you. I'm just going to say it, so you just listen. So it will be, the value of cube root is what? 1 over 3. Then we multiply it by this one because it is already in the exponent position, and that will give us 4 out of 3. So this one is the same thing as tangent. This one is the same thing as tan x raised to the power 4 over 3. So cube root of tangent x to the power 4 is the same thing as tan x raised to the power 4 over 3. Now when you are differentiating, you know the power rule. That is, multiply the exponent by the base. That is 4 over 3 times, then differentiate the base. So when we differentiate tangent x, we are going to get what? Secant x squared. So it will be 4 over 3 times secant x squared. Then we decrease the power by 1. So 4 over 3 minus 1 will give us what? 1 out of 3. And 1 out of 3 is the same thing as what? Cube root of what? Tangent x. Cube root of what? Tangent x. Okay? So when we differentiate this, you're going to get 4 over 3 times secant x squared times cube root of what? Tangent x. What about this one? How we interpreted this is the same thing as what? This one, but just that this one here, it is what? 2. So instead of here getting 4 out of 3, here we will get 2 out of 3. And then when we differentiate, you're just going to get the same thing, but this time in a different way. Why? Because when we decrease the power by 1, we are going to get minus 1 over 3. Minus 1 over 3. So the answer to this one will be 2 over 3 times secant x squared times tangent inverse of tan x to the power minus 1 over 3, which is the same thing as what? Cube root of what? Tangent x, but to the power minus 1. So to simplify, we will write it as 2 times secant x squared all over 3 times cube root of what? Tangent x. And it is because we had the cube root of tangent x to be what? Negative. Okay? So when we differentiate this, you're going to get df. Differentiating 1 will give us what? 0. So not waste time on it. So when we differentiate this one, you're going to get 4 over 3 times secant x squared times what? Cube root of tangent x minus 2 times secant x squared over 3 times cube root of what? Tangent x dx. Don't forget that. Alright, so this is what I was talking about. This one, 4 over 3, that is 4 over 3, but the whole of this 4 is multiplying the whole of this, so it's the same thing as well. 4 over 3 times this, and that one is the same thing as well. This one, okay? So this one, I hope it won't confuse any. It's not I hope, I know it won't confuse any because we have been doing that a lot. So it's not anything new. It's very simple. Yeah, sure. So this one too is as I said, 2 secant x squared over 3 cube root of what? Tangent x. All right. So here, what we are going to do here is that, when you write this one as a single fraction by, multiplying this one by this and then give it one denominator as 3 cube root of tangent x, and then this one times cube root of tangent x to the power 2 minus 2 secant x squared all over this. Is let's say is a good idea to do it that way. Even if you do it that way, you still have to rationalize the denominator. So actually I'm not going to do it like that. What I'm going to do here is that I'm just going to rationalize this fraction. I'm just going to rationalize this one before I'm just going to rationalize this one before I just subtract this one from this and write it as what? A single fraction. You can do it as what I said earlier, like you multiply this one by this and also this one by this, and you write the denominator as what? 9 cube root of tangent x. After that, then you rationalize. Yeah, it all depends on you. But here to make it very simple, first let's rationalize this one, because with the cubes, how we rationalize radicals, when I say radical I mean square roots, it's not the same thing as what? How we rationalize the cubes. Hope you are getting me. If this one appears to be a square root, yeah, we can go ahead, do it that when you are rationalizing, it will still be very simple. But if you, I'm not saying it won't be simple. Yeah, it will be simple if you know how to deal with the cubes. But if you don't know how to deal with the cubes, just let's go by what I'm going to say. Okay, good. So that does not mean I don't know how to deal with the cube. If I go by that way, a lot of questions going to be asked, and most of us will find it difficult to getting the understand, because with the cubes, it's not that simple. It's not that simple as compared to the radicals. Yeah, as compared to how we deal with the square roots. So here we will rationalize this one. But how do we rationalize? Remember, if this one appears to be a square root, when you are rational, you just multiply top and down by the square root and you are done. But mind you, the motive of multiply top and down by square root was that the value of square root is what? 1 over 2. So we only need extra square root to make the value of what? The square root to be 1. We need additional 1 to make it to be what? 1. When it becomes square root raised to the power 2, the square goes off. But here is what? 3, 1/3. So we need additional 2/3 to make this one what? 1. So if I want to get rid of this cube root here, cube root sign, I need additional 2 cube roots. Why? Because the value here is what? 1/3. And in order to get a whole, you need additional 2/3. 2/3 plus 1/3 will give you what? 3 out of 3, and that will give you what? 1. So here, the idea here is that we are going to multiply top and down by cube root of tangent x raised to the power 2. When you do it like that, this side will become what? 3, and this side will go what? Away. Alright? So rationalize the denominator, and that is how we are going to rationalize. All right. So as I was saying, here we need additional 2 on this side to make this one what 1, but here we don't have any additional any extra 1 here to make this one. So this one we will just leave it as it is. We multiply this one by this and we are good to go. But here, when it is multiplication, according to the law of indices, we just add the powers. When it is multiplied, we just add the powers. So this times this, they are having the same base. So we are having 1 here, and here we are having 2. So 2 plus the power here is what 1. So 1 plus 2 give us what 3, or 1 out of 3. When it is times, we add plus 2 over 3 will give us what 3 over 3, right? Good. And here when we multiply this one by this, it will just give us 2 secant x squared times cube root of tangent x to the power 2. Good. Yeah. Now let me give you something here. Anytime we see in this video, if you see any of the figures or anything being changed with different color, yeah, I mean when during the working, it means it's going to do a cancellation. Yeah, it's going to do a cancellation. So that is the clue. But if you see the whole thing being highlighted in different color, either it is an answer or there's something to differentiate, something to something to be differentiated from what we are doing. But it's the same thing, but it is in a different form. It is either an answer or maybe something that we will come and look at again. Okay, so in this one here, it means you're going to do cancellation. So as you can see, here we are having 3, and then here we are having what 3. It means that the this sign can go off, because now this and this are the same, or is the same. So this 3 will just take off this cube root sign, and to be left with what tangent x multiplied by this 3, and it will give us 3 tangent x. Okay, so now we can go ahead and then write this one as a single fraction. So let's look at the LCM. Here is 3, and then here is 3 tangent x. So we only need tangent x here to make the denominators to be the same. So we can do this one in 2 ways: by multiplying top and down of this fraction by what tangent x. When we do that, here will be 3 tangent x, and the denominators will be the same. We will just add what the numerators, or we will multiply let's say tangent x by this one, we multiply tangent x by what this one, and then we subtract this one from it. I mean, when you look at the LCM, that is how it's going to be. If you put the LCM there, here we are having the LCM will be 3 tangent x. So when you look at the LCM, here is 3, and when you go to the other one, we are having 3 tangent x. So 3 tangent x, 3 will cancel out with 3 and to be left with tangent x, and tangent x will just multiply this denominator. So it's the same thing as what I just said. So we multiply this one by this, then we subtract this, and then we divide it by what? 3 tangent x. Okay, good. All right, so 4 secant x squared multiplied by tangent x times cube root of tangent x minus 2 secant x squared multiplied by cube root of tangent x to the power 2 divided by 3 tan x, all dx is the derivative of what? The cube root of tangent x to the power 4 minus cube root of tangent x to the power 2 plus 1. That is the answer to that derivative. Okay, what is inside? When you differentiate what is inside this bracket, this is what you are going to get. You see, it is different from how we rationalize square root. You know, with square root, this side would have been what? Just one thing, but you see this one here you are seeing what the power 2. You are seeing what power 2, but if it appears to be what square root, this one will just be what a square root of tangent x. But because it's cube, look at what you are seeing. It is what? Cube root of tangent x to the power 2. I hope you guys are okay. Sure, let's move on. So we are now going to look at the derivative of what? The original equation. I mean, in terms of A. In terms of A, we are going to look at the original equation. After that, we will multiply whatever we will get by the whole of this. Alright? Good. So U is equal to 1 over 4. It was 1 over 4 something, but not this F. But we want to make it simple. That is why we bring in the F. So it is now 1 over 4 natural log of what? F. And the answer to this one is very simple. That is 1 over F. So du is equal to 1 over F df. So we're gonna get du is equal to 1 over 4 F. 1 over 4 F. 1 over 4 F. But here we are done differentiating, but not done. Why? Because we have to see the application of the chain rule by bringing in what we substituted this F for and what this df is what representing, or what this df is being equated to. Remember the other part, we had df is equal to 4 cube root of 4 secant blah 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 blah. Yes, if you want to finish differentiating the A part, we have to bring in what we equated this one for, what we substituted this one for, and also what this one is what being equated to. Okay, so we are going to do that bit by bit. First, we are just going to bring in what we substituted this F for. That is what the cube root of tangent x to the power 4 minus blah 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 blah. After that, we will just bring what this one is equal to. So, but F is equal to cube root of tangent. I'm writing this one for you because from where we start, some of you might have forgotten. So that's why I'm writing this one for you. So remember, when we started the solution, we equated F to this one. So now that we are done with the differentiation, we have to put it back. So wherever you see this F, please just don't go and replace this one here. If you do that, you're just confusing yourself. This one has its value, and also this also has its value. Alright, so we are going to let wherever we see we are we're going to put this f be equal to this one here. After that, we will put the answer that we have to derivative of this here. This f is representing the derivative of what? The whole of this. Okay, all right. So the whole of this one is being multiplied by 4. Whole of this one is being multiplied by 4. Don't confuse yourself. Yeah, don't confuse yourself. The whole of this is being multiplied by 4. So it's 4 into bracket cube root of tangent x to the power 4 minus cube root of tangent x to the power 2 plus 1. Now let's replace this one too. Let's replace this one too. That one is also equal to what? But df is equal to this one, but df is equal to this one. That is 4 secant x squared times tangent x times cube root of tangent x minus 2 secant x squared times cube root of tangent x to the power 2 divided by 3 tangent x, all multiplied by all dx. So wherever you see df, you put this one there. All right, now we are seeing the application of the chain rule. You know, the something over this x multiplied by the something over dx. You see, that is what you are seeing here. Ideally, it's supposed to be du over dx, but because we want to because we want to make it simple, we did substitution. And because we did the substitution, it changed to du over df. So we have to find the dx back by bringing in or by applying what? The chain rule. And I don't know, do you see we've gotten our du over dx back by replacing what this one is being equated or to, which is what? This one here. All right. So this multiplied by this, what can we do? Any cancellation? What can we do? Well, okay, we can do cancellation, but before we can do cancellation, we have to first here we are having 2 here. We are also having 2 here, 4 here. So we can factor out 2. We can also factor out secant x squared and also cube root, but when you factor out cube root and then secant x squared, it cannot cancel out anything here, so we will not bother. But when we factor out 2, it can cancel out what? This 4. That is what we are going to do. So we're just going to factor out what? 2 from here, and then we use it to cancel out what? This 4. So these 2 here cancel out with this 4, and that will give us what? 2. So here will be multiplied by. Now when you do the cancellation, here there is nothing that we can do again, so you just multiply everything, denominator by denominator, numerator by numerator, because there is nothing else that we can do again. All we got to do is just to write it as a single fraction. So here we are going to get 2 So on the top here, it will be 1 times the whole of this. So that will give us 2 secant x squared times tangent x times, so cube root of 4 tangent x, minus secant x squared times cube root of 4 tangent x squared, divided by here we are getting 2. So 2 by 3 will give us what? 6. By this one will give us what? 6 tangent x. So 6 tangent x by this one will give us what? 6 tangent x times the whole of this. Remember what I said? When you see everything being highlighted, it means we will come back and work on it again. We will use it for another thing. But when it's a single thing being highlighted, it means just going to cancel out. So this one means we will use this one for another thing again. That is why I highlighted it in another color. Okay, so guys, that is the answer to the derivative of what? The A part, which is the 1/4 natural log of cube root of tangent x to the power 4 minus cube root of tangent x to the power 2 plus 1. Now the derivative of that A part, this is the answer to it. So when you differentiate it correctly, this is what you are going to get at the end of the day. And as you guys are seeing, it is something else. It is something else. But the question is, the other part we did some rationalization, but here aren't we going to do some rationalization? The question is, just look at this one. Just look at this denominator. How are you going to rationalize it? So I'm not saying it is not possible. It is possible. We have a way of rationalizing the denominator in terms of rationalizing the denominator when it is in what? A cube form. When it is what? A cube form, and it is more than what? 1. Like as you are seeing here, we have a way of doing that. That is, we apply this thing, that is a cube plus a cube is equal to a plus b into bracket a squared minus ab plus or b squared. You know, when you expand this, you're just going to get a cube plus b, a cube plus b cube back. Yeah, you're just going to get it back. So that's what we use in rationalizing cubes, but we're not going to use that one here. So let's leave this one as it is. We don't know, maybe whilst working at that part, maybe whilst we are continue doing the workings, we might get one of them, one of the tools. Yeah, we might get one of them to have the same denominator as you are seeing here, which will make our addition and subtraction easy at the end of the day. So when we waste time bothering ourselves of rationalizing the whole of this before we move on, we are going to waste a lot of time. Okay, it's just going to waste a lot of time. Though at the end of the day, we will still do some rationalization to get our final answer. But for the meantime, let's maintain this one and then find out from the other ones if we can get some of them to have the same denominator as this or not. That is the reason why I'm not rationalizing. But as for the other part, if we have to do the rationalization. You can also leave it. I said you can also leave it and then do your workings. At the end of the day, you have another cube root. You have another cube root in addition to what you are seeing. You have the whole of this multiplied by another cube root. If you deal with the cubes very well, but if you don't deal with it very well, you will not be able to get additional cubes that are being multiplied by this denominator here. No matter what you do, the denominator at the end of the day is just going to be in the form of this, unless you rationalized. Okay, So this is the answer to the A part. That is the derivative of 4, the 1 over 4 natural log of 4, blah 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 blah. That is the answer to it. Now we are done with the A part, so let's move on to the B part and see what that one is also going to give us. Any questions so far? Please, if you have any question, I know most of you are going to ask questions because of how the cubes are, but you don't worry. If you have any question, just let me know either in my email or you leave in the comment section. If you don't want somebody to see your question, or if you don't want somebody to see your question, just leave it, send it to me in my email. Okay, just send it to me in my email. So when I see it, I'll just try and do my possible best to answer you. So as for this one, I'm ready for you guys. Any question that I want you guys to get the understanding. So whatever question that you have, just make sure you let me know in the comments. I hope most of you ask questions about how to rationalize this one, provided this one is not there, like 1 over maybe the whole of this. Yeah, I know some of you is just going to ask question on that, but for that, as I said earlier on, we do that by using what? A cube plus B cube is equal to what I said earlier on. Alright, now let's move on to the B part. But if you have any question, just let me know in the comment section and I'll respond to it for you. Alright. Okay, I'm writing the B part for you, but just to avoid waste of time, you just let a variable be equal to 8. We always do that because of the substitution. No, when you are using the chain rule, we do that, but that is why I said it is what indirectly. It's not the same thing as what the chain rule is being used. So this is the B part. That is square root of 3 over 2 times tangent inverse of 2 times or cube root of tangent x to the power 2 minus 2 all over cube root of 3. Alright, as we did for the other part, we are going to let another variable be equal to this one. Then we will differentiate it. Whatever you get, you multiply it by the derivative of what? Square root of 3 over 2 times tangent inverse of whatever variable that is going to be here. So you are going to let m be equal to what is in this bracket. What is in this bracket? Alright, so we are going to differentiate, but before we do, let's split it into like fraction. Now anytime you have something of this form and you want to differentiate, I will entreat you to split it into like fraction. When it is in this form, like something of this nature, it means it was having what? The same denominator. When you split it into it was having the same denominator. So splitting it to like fraction means giving each one of them the same denominator. That is what? Square root of what? 3. So when you write this one, it will be this one over square root of 3 minus this one over square root of 3. When you solve that, I'm just going to get this one back. Good. So now let's split into like fraction. I'm saying like fraction because this one will have the same, the denominator for this one will be the same denominator for this one. At the end of the day, is what? Like fractions. Like fractions. So DM, you're gonna differentiate, right? Remember, anytime we differentiate, constant is 0. So here we all know is 0, so we will not let's forget this one and let's focus on this one. Okay, so we're gonna differentiate this one, but Still is very simple. The main focus is going to be on this one. Cube root of tangent x to the power 2. Cube root of tangent x to the power 2. As for this one, you just forget it because the answer is just 0. Okay, this one, if you want to avoid difficulty, you can also rewrite this one by, you can also rewrite this one as 2 over cube root of 3 times 2 over square root of 3 times cube root of tangent x to the power 2. When you do it like that, maybe it will help some of you put in their mind that at the end of the day, the focus is on this one, and then they're just going to maintain the 2 over square root of 3. You just maintain that 2 over square root of 3, and then you differentiate the cube root of tangent x to the power 2. The motive is just application of all the product rule. So just maintain the 2 over cube root of 3. But still, when it is in this form and you are differentiating, just let your focus be on wherever the variable is. The variable is what? The most important thing. The figures involved, just forget them. I'm not saying you should forget this figure. If you forget this one, you get your answer wrong. But like something like this, like 2, like how you are seeing it. If there is another one here, maybe times 3, we will just multiply the times 3 by this one, and also divide it by this one, and then let it be there, and then differentiate this one. Because when we are differentiating, actually the product rule will tell you that this one will not be all that affected. Even if it is affected, the other part, the product rule will explain, the other part will give you 0. I don't know, they are just still going to get what? This one back. So just maintain it and then focus on this. What do you think? Yeah. So we're just going to put our focus on this and this. Let's maintain it. So we're going to put our focus on this. Now when we differentiate, here the value of the cube is 1 over 3, as I said in the other part. Multiply by this exponent to give us 2 over 3. So already we are having, that is why I said you can rewrite it. That is, already we are having 2 over cube root of square root of 3. So it will be 2 over square root of 3 times, now we multiply the power by the whole of this, that is 2 over 3 times, then what is the derivative of tangent is secant s squared, right? So when we differentiate tangent, you're going to get secant s squared. Then we decrease the power by 1. So 2 out of 3 minus 1 give us what? Minus 1 out of 3. So when we differentiate this, you're going to get 4 times secant s squared all over 3 root 3 times cube root of 4 tangent x. I hope you are okay. Yeah. So dm is equal to so this was just to show you what I just said. The same thing as what? 2 over 3 times 2 over square root of 3 times secant s squared all over this one. Alright. Now when you compute this, you're gonna get dm is equal to 4 secant s squared times cube root of tangent x Alright, somebody may ask, oh, the next lesson I thought we were going to see 4 secant s squared over 3 square root of 3 cube root of multiply by cube root of tangent x. Yes, in the other part, the next step is supposed to be what I just said, but when you write that one, you have to also rationalize the denominator and get this one. And here I did it directly. So what I'm going to say is just to do the explanation here. Yeah, I'm just going to do that. The other part you saw how we rationalize. So I thought this one I can just make it fast. I can just make it fast. When you write that, if the answer will be just going to give us 4 times secant x squared over 3 root 3 times cube root of 4 tangent x dx. But at the end of the day, we have to what? Rationalize. The other part, remember, we rationalize. But how do we do the rationalization? Remember, here the cube is what? 1. The power here is what? 1. If it is 1, we don't indicate. Okay? So, how can we get the power to be 3 so that this sign will go off? By bringing in additional 2. And with this one, we cannot bring in additional 2 to this one without multiplying this one by sum. So we have to multiply top and down. The motive of multiplying top and down is that if you want to get this one back, at the end of the day, what you use to multiply the top and what you use to multiply the denominator will just cancel out and to just give you this one back. So anytime you are bringing something, you just do it in such a way that if you want the original one back, it is easy to get it back. So we're just going to multiply this one by cube root of tangent x to the power 2, and also multiply this one by cube root of tangent x to the power 2. Now when we do that, cube root of tangent x times cube root of tangent x to the power 2 give us what? Cube root of tangent x to the power 3. And since the power has become 3 and the value of the cube is also 3, it just cancels out and to give us what? Tangent. That is why you are seeing this tangent here. So the next step should have shown for this all over this one before seeing this one. But because we did the other one in the other part, I decided to go fast a bit. Okay, but don't worry, I've just explained it. So if you missed that part here, you have seen why we had this one. Okay, so this is the answer to what is the derivative of what is in the bracket of the tangent inverse of the bracket of the tangent inverse. So dm is equal to 4 secant x squared times cube root of tangent x to the power 2 all over 3 root 3 tangent x. Now let's move on to the original part. I mean, when I say the original part, I'm not saying the original question, but the original B. We are moving on to where we have to differentiate the original B, where we pick these ones from. We have to differentiate the other one too. Okay. After that, we will just put this one to replace dm in the other part, and then we are good to go. Okay, k is equal to square root of 3 over 2 times tangent inverse of m. Here, I'm not going to show you how the derivative of tangent inverse is arrived. I'm not going to show you that, but we know the answer to the derivative of tangent inverse. I've already told you that when you see a number attached to a variable and you are differentiating, let your focus be on the variable. Here, our variable, the variable here is m, but it's tangent inverse of this. So the focus is on this tangent inverse of m. Just forget this one. At the end of the day, whatever we had to this one will be multiplied by this. Okay. So what is the answer to the tangent inverse of m? You already know why derivative of tangent inverse of m is equal to what we are going to write. So there is no need for me to prove. Yeah, there's no need for me to prove. You can do the proof yourself. Alright, that's just by the way. But I hope you are enjoying this video. I hope you guys are enjoying it. Though I told you that the cubes are something else, but when you get to know how to handle them, you see, it becomes very simple and it's all fun. The more you are working it, the more you are just giggling because of how you have gotten to know how you are handling the cubes. It's fun, provided if you have went on rationalizing everything, it would have make the situation very tedious. Okay, so you see how we are dealing with the cubes bit by bit. Yeah, that's how we deal with cubes in differentiation. Cubes, I mean, I said cubes, not square roots. I mean cubes. You know, we deal with them small. If take all of them at once, Charlie, it won't be all that easy. Okay, all right. So the answer to this one, the derivative of tangent inverse of any variable is just 1 over that variable squared plus 1. 1 over that variable squared plus 1. So the answer to this one is the k is equal to root 3 over 2 times 1 over m squared plus 1. 1 over m squared plus 1. Okay, so as I said, we have to multiply this one by this one. Now when you multiply this one by this, you're gonna get square root of 3 over 2 into bracket m squared plus 1. All right, so the b part, I mean, when we consider the tangent, this is what we are going to get. So the derivative of the tangent inverse of m has given us what this, but we have to bring in what we equated the m for, what we equated the m to. Okay, we have to substitute in what the values for what m, and later on we just bring what this one is being what equated to. Okay, so let's first start with this one. But don't worry, I will still write that one for you to see. But m is equal to, remember we equated m to this one. Good. But the other part, you remember it was m squared. If you put this one, you can put this one into that where you are having the m squared, and then square this whole thing and then deal with it. I'm not saying it is wrong. You can do it that way, but just bear in mind that if you can do it that way, good, perfect, nice, nobody cares. But if you think putting the whole of this one there and then squaring it will give you a problem, just find the value of what m squared to this one, and after that you just put it what there. So here m is equal to this. We are just going to square both sides so that the whole of m squared will be equated to something. Here is just m is equal to this. So when we put this one there, we have to bracket this and then square it again. So to avoid fumbling on that part, we are just going to find m squared, so that when we go there, we know that m squared is this. So that this will just be put there, and then we are good to go. So first, let's find m squared. So we are just going to square both sides. We will square this one and also square this one. So m squared will be equal to, so that is how you will do it when you replace this one in that bracket. I mean, where you're having m squared plus 1, this is how you do it. And then you expand this one there plus the 1. But here, as I'm saying, you can choose to do it this way. So when we go there, when you see m squared, we put this one there. But first, let's expand this one so that we can handle that part very well. What do you think? Yeah. Well, if you don't want this one, you can also go ahead and put this one there, square it, open it there, and then continue from there. Nobody cares. I just want you to get the understanding. That is why I'm doing it bit by bit for you. Alright, let's expand. Now when you are expanding, remember we have Pascal triangles, which indicate the value of what each power in expression. How we expand expression which is being raised to a particular power. Like when you are having a plus b to the power, let's say 2. The numbers involved, that is the coefficient, is what? 1, 2, 1. If it is 3, 1, 3, 3, 1. I'll find time and then walk you guys through that one also. We call it Pascal triangle. It helps you to expand a bracket or a term or expression which is being raised to a particular power. Provide, especially when the power is what? Is more than 2 going. More than 2 going. We normally, for 2, we all know how, when the power is 2, how it is what? Expanded. But we normally make reference to the Pascal triangle when the power is what? More than 2, maybe 4, 5, 3 is 1, 3, 3, 4 is 1, 4, 6, 4, blah, 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 something else. But I'll find time and then walk you through that one later on. But here, that's what we are going to use to expand this one. So when it is 2, it is going to be, when you pick the first one, the coefficient is, it's just going to be a squared plus minus, or maybe plus 2 times a times b, that is a squared plus or maybe minus 2ab plus b squared. I hope you are getting me. That's what you are going to use to expand this one. So first, we will expand this one. We will square this one, the whole of this one. After that, we will multiply this one by this one, the whole of this one, and then multiply it by 2. After that, we will take minus cube root of minus 1 over square root of 3, then we square it. That is what? A squared plus 2ab plus what? B squared. Okay? Now, when we square the whole of this, let's take it one by one. When we put bracket here, and then we square, every item in here is being affected by the power 2. This one is affected. This one too is affected, but because this one is a value to this one, because this one is a value to this one, so the whole of this one is affected. But because this one is under this one, the whole of this one is affected. So the affection of this one is applied to this one, or this one is applied to this. If you apply it to this one, it means it is attached to this one. There will be no need for you to apply to this one again. If you apply to this one, there will be no need for you to apply to this one again. How do you apply to this? The value for this one is 1 over 3. Square it, you're just going to get 2 over 3. That's it. So if you put tangent to the power 2 over 3, and you want to convert it to in a form of cube root, just write it as cube root of tangent s to the power of 2. Assuming you don't have these two there, that's how you're going to do it. So you see, this and that is being affected at once. But this one here, we are having another 2 here. So it means this 2 is affecting the whole of this. So if another bracket is here and being raised to the power 2 again, it simply means that the whole of this is affected. This one is affected, and then this one is affected. So we will square the whole of this one, the whole of this. Just look at how I'm doing it, the whole of this. After that, we square this, and after that, we square this. Okay, so this one will give us 4 times. Now, when you square this one, just 2 times 2, and that will give us cube root of tangent s to the power what? 4. When you square this one, we're gonna get what? 3. So when you open this one, you're gonna get 4 times cube root of tangent x to the power 4 all over 3. And then minus, remember I said you multiply this by this and you multiply by 2. So it's going to be minus 1 over square root of 3 times 2 times cube root of tangent x to the power 2 all over square root of 3 times 2. And that is going to give us 4 over 4 times cube root of tangent x to the power 2 all over 3, because square root of 3 times square root of 3 will give us what? 3. And then the other part will be minus, please don't take only the 1 over square root of 3 and then square it. No, this one is attached to this one, because when we were multiplying the 2ab, we included this sign there. So if this sign appears to be positive, the expression could have been 2a squared plus b 2ab plus b squared. Now the expression is minus, so it will be a squared minus 2ab, then we take the whole of this, then we square, plus b squared. Good. So this will just give us 1 over 3. 1 over 3. So m squared is equal to so this is what I was saying, as we are seeing here. That is this one times this one here, this by this, and then times this. And we consider the whole of this. We didn't only pick this one. So it's minus 1 times this one, and then times this one. Okay, good. So this and this will give us 3. And then this by this by this will give us what? 4. And then when you square the whole of this, you just get plus what? Plus 1 out of 4, 3. Okay, so m squared is equal to good. So when we see m squared, we will just write this one there, and it's the same thing what you are going to get when you replace m to be the 2 times cube root of tangent x to the power 2 over square root of 3 minus 1 over 3. When you put it there and then you square it, that is what you are going to get at the end of the day. Okay, goodbye. When you do it this way, make it very simple. When you go there, you will save time of what? Just expand it again. Just go add it to it, and then you are good to go. All right. So now let's replace this one there. So decay is equal to and then plus 1. Very simple. And then plus 1. Very simple. Now here 1 over 3 plus 1. That is 3 plus 1 will give us what? 3 times 1 will give us what? 3. And then plus this one give us 4. So here will give us what? 4 over 3. 4 over 3. And then what will you do? When we get 4 over 3, we have to, since all of them are having the same denominator, we will just write it as 4 times cube root of tangent x to the power 4 minus 4 times cube root of tangent x to the power 2 plus 4 all over 3. Then we will send the 3 to the numerator's position. Okay, so here we are going to take this, bring this 3 to multiply this one. That will give us what? 3 times square root of 3, and that will be 3 root 3. 3 root 3. And then here too we can factor out the 4. So when we factor out the 4, to multiply this one and to give us what? 8. 8. Alright, so decay is equal to 3 root 3 over 8 into bracket cube root of tangent x to the power 4 minus cube root of tangent x to the power 2 plus 1 dm. But we already know what this dm is equal to, so there's no need for us to worry. But remember the other part, we had a particular denominator to be on this one, though something was attached, but we had this one as part of the answer to the A part. Remember, that is the reason why I said we shouldn't waste time of what? Rationalizing that whole denominator, because it might be that we might get the same thing for some of them as we are working the other ones. So you see, what I told you earlier has been what? Reflected. We have gotten what we had for the other one to be the same denominator for this one. Alright, so let's replace dm is equal to what? Dm is equal to dm is equal to this one. You're gonna put dm here. You're gonna put dm here. So wherever you see dm, you're gonna put this one there. You're gonna put this one here. So dk is equal to alright. As I told you, when you see figures being highlighted, it means cancellation. It means cancellation. So here, just going to do cancellation. Just going to do cancellation. Alright. 3 root 3. Let's come here. You can cancel out with this 3 root 3 here. Yes. So it will just cancel out with this one. And then you will get this. And when you come here, 4 can go into 8. How many times? That is 2. So you will get 1 multiplied by the whole of this, and here also you will get 2 times the whole of this multiplied by tangent x, and that is going to give us 1 times this one will give us what? Secant x squared times cube root of tangent x to the power 2 divided by 2 times tangent x times this one. So dk over dx is equal to meaning we are going to work on this one. You see, the other part we had 6 times tangent x times this one, and this part we have gotten 2 times tangent x times this one. That is the reason why we didn't waste time of what? I told you not to waste time of what? Rationalizing that denominator. We don't know what we are going to get for c. It might also even be that you will get the same denominator for what? C. For c also, I mean, you get this one to be in the denominator's position for what? C. Whatever you are going to get for c, it might be that you get the same thing what? Here. Okay, so guys, the derivative of b, which is the square root of 3 over 2 tangent inverse of 2 times cube root of tangent x raised to the power 2 minus 2 all over, minus 1 all over square root of 3 is equal to this one. So when we differentiate it, this is what we are going to get. Now here, this one, it means we are still going to, we will work on it again. That is why I've highlighted it. Alright, now let's move on to the C part. If you have any question, please make sure you leave in the comment section. But I hope you are enjoying this video. I hope you are enjoying it. It's very, very entertaining. It's very fun, though it's not that fun, but still it's fun, okay, because of the cubes. And I hope if you are enjoying it, please don't forget to subscribe, share, like, and comment, and thanks for doing that. Okay, now let's move on to the C part. Alright, let's move on to the C part. Okay, with this, you're gonna let P be equal to natural log absolute value cube root of tangent x to the power 2 plus 1. I hope this one you can even pause the video and try, because even the lengthy one, the complex one, we have been able to do it. How much more this? I hope you can pause the video and try. Come on, you pause the video and try before you come and continue watching, because with this one it's very simple. When you do it and you get it correct, it means you have learned. But well, if you get, don't worry, we're just going to learn it. That is why we are watching this video. Okay, so the same way, we're going to let another variable be equal to what is in the bracket here. What is in the bracket? That is cube root of tangent x to the power 2 plus 1. So we are going to let a variable be equal to that. Then we differentiate. After that, we will come and look at P is equal to the natural log of that variable. We differentiate that, and then we will multiply the derivative of the P, or the P over that, the P over that variable, and also multiply by that variable over dx, and then you get the answer to the derivative of what? The whole of this. Okay, so we're gonna let z be equal to this. Now the z will be equal to what? Remember, this one is the same thing as what? 2 out of 3. So you're gonna get 2 over 3 multiplied by, now you differentiate this, multiply by secant x squared, and then times 2 over 3 minus 1 will give us what? Minus 1 out of 3. So times cube root of tangent x to the power minus 1. Then we write it as 2 times secant x squared all over 3 cube root of 4 tangent x. When we differentiate 1, we're gonna get 0. So the z will be equal to 2 secant x squared over 3 cube root of tangent x dx. Cube root of tangent x dx. You see, very, very, very simple. Very, very, very simple. But the reason why I said you should pause the video and try is that the first two were those that were very confusing, and it will, no matter what you do, it will prevent you from trying your hands if you don't know how to deal with the cubes. But because we have solved one and an additional one on the same question in the same way, I mean the cubes, how we handle the cubes, I think trying this one won't be a problem, because there the cubes were even more than one, and here you're only having what? 1 cubes. So if we have been able to manage or handle more than 1 cubes, how much only 1? You see how much only 1? More than 1 we've handled it. How about only 1? That's why I said you should pause the video and then try. So here, what are you gonna do? Yeah, that is what? Rationalized. But we need what? We need what? I did in the comment section. We need what? 2. Good. Yeah, good. Thanks for your answer. We need what? 2. Good. So I'm going to multiply it up and down by cube root of tangent x raised to the power 2. So rationalize the denominator. That is, we are going to multiply it up and down by cube root of what? Tangent x to the power 2. Okay, so this times this will be 3, and that 3 will just cancel out with this one, so it will give us 3 times tangent x, and then this times this will give us 2 times secant x squared times so cube root of tangent x squared. Good. Okay, the derivative of the cube root of tangent x to the power 2 plus 1 is this one. Now let's move on to the other one, that is where we have the main one. So p is equal to 1 over 2 natural log of z. This one too, you can do it. You see, that is the reason why I said you can pause it and solve the c part, because the c part is very simple to tackle. So the p is equal to 1 over 2 times 1 out of z, and the p will be equal to 1 over 2z, but z is equal to something, that is what? The square root of cube root of tangent x to the power 2 plus 1. So we have to replace it z with what? The cube root of tangent x to the power 2 plus 1. But I'm writing that one for you just to remind some of us, of course. As we are moving on, there are some of them that we'll be forgetting, unless maybe you pen them down and you pen them down and use that one to follow. Okay, so but z is equal to this. So you're gonna put this one here. Okay. All right. So what are you gonna do? You have to also find something to replace this one. So the z is equal to what? The z is equal to 2 times secant x squared times cube root of tangent x raised to the power 2 all over 3 tangent x dx. We're going to replace the z with this one. So dp is equal to Alright, so here this will cancel out with this. Any other cancellation? The answer is no. There's no cancellation. There's no other cancellation. Alright, since there's no other cancellation, we just multiply this by this and then this by this. And that will give us secant x squared times cube root of tangent x to the power 2 divided by 3 tangent x multiplied by cube root of tangent x to the power 2 plus 1. So dp over dx is equal to secant x squared times tangent x raised to the power 2 divided by 3 tangent x times cube root of tangent x raised to the power 2 plus 1. You see, as I told you, all those being highlighted in a particular color are going to be further worked on. Now that we are done with the derivative of each and every one of the answers in the original question, we are then going to look at the computation aspect. We're just going to add and then we subtract some. Add some and then we subtract some. So from the original equation, it was a plus b minus c. But first, we are going to add a and b. After that, we will, so whatever we will get, we subtract c from it. It's the same thing. Either you subtract c from a or from B, and then whatever you get, you add it to the addition of A and then B. You're just going to get the same thing. Anyhow you do it, it is going to get the same thing. You can also add all of them at once, and then you still get your answer at the end of the day. It is all depends on you. Anyhow you do it, it's going to get the same answer. Okay, but here we're gonna do it bit by bit. We're gonna stick to the original equation. So the first is A and B. You will just first add A and B. After that, whatever you get, you subtract C from the answer. Please don't add A and B and later subtract C from B. If you do that and you add the answers, you might get it wrong. Maybe you might get it right, but handling the cubes, finding the means to get the answer will be difficult. So to avoid that, first add A and B. The answer that you get, subtract C from it, or add all of them at the same time. Okay, so first we are going to look at addition of what? A and then B. Addition of A and then B. So add the derivative of A and B together. A and B together. But what is the derivative of A? A is du over dx, and then B is what? dk over dx. But this one, that is the reason why I highlighted them in different colors. So I'm just going to use those colors here, so that when you see it, you see that this one is representing this is representing that, and after that I'll just let them be in another color, but all will be in what? The same color. So this is representing A, and then this is representing B. Yeah, sure. So this is A. This is the answer we had to A. Yeah, remember this is the answer we had to A. And now this is the answer we had to B. Good. That is the reason why I didn't change them initially. Yeah. So this is A, and then this is B. Now we are going to what? Add. But the question is, how are you going to add? Find the LCM, and then we add or subtract. Very simple. But mind you, let's look at something here. Just look at this one. The same way, but let's look at this one too. Whatever that is here, the same thing as what is here. This one, the same thing as this. The only difference is, let's forget about the numerator. The most important thing is what? The denominator. If you get them to be the same, dealing with the numerator is not a problem. Always the denominator is what? The problem. Here we are having 6. Here we are having 2. The difference is what? 4. But in terms of multiplication, it is what? 3. So what can we do so that what is here will be the same thing as what is here? Yes. Can anyone help me out? I hope you have gotten it. That is, yes, sure, I like what you said. That is, you multiply this one by 3. You know, when you multiply this one by 3, it will be 6. But the question is a fraction. We don't have any 3 here, as you guys are seeing. We are just finding the means to make this one be equal to what is here. So if we bring in the 3 and then we multiply it to only this one, it will make our answer wrong. Why? Because at the end of the day, if you want to get this denominator back, it will not be possible. So the only way to make it possible is to what? Multiply top and down by 3, so that at the end of the day, it will just cancel out. So we multiply this one by 3 and also the whole of this one by 3. Well, so that this one will be 6, and you will just focus on the numerator, and then we just add and subtract. So this one will be multiplied by 3, and then this one also be multiplied by 3. Okay, so this by this is what? 6. This by this will give us 6. And this by this will give us 3 secant x squared times cube root of tangent x to the power 2. All right, now what is here is the same thing as what is here. Now you see, if we had rationalized this one in the A section, you see, it could have given us another problem. We won't be able to make this and this to be the same unless we rationalize this one too, and it will make addition of the numerators very difficult. But looking at this, the addition is going to be very simple because only this and this are the same. Here they are all the same, so we're just going to look at one denominator and then we subtract this one from this, and it becomes very simple. So you see, it's fun but not all that fun. It's fun but not all that fun because of the cube. But if you know how to deal with the cube, if you got to know how to handle the cubes, working it is very, very, very fun. You just start and you will not pause, you not stop at anywhere until you get your answer. You just be moving on, but just be confused and something else. Okay, all right, so the denominators are the same, so let's add the numerator. That is, this one is the same thing as this, but here is minus secant x squared cube root of tangent x to the power 2. Here is 3, here is only 1, so 3 minus 1 will give us what? 2. So we are going to get 2 secant squared, 2 times secant squared x times tangent x times cube root of tangent x plus 2 secant x squared times cube root of tangent x squared to the power 2 all over this. Alright, so the denominators are the same, you just write 1. So this minus this plus this will give us what? 2. We just give us what? 2. Yeah, addition of A and B has given us what? This answer. So as I told you, please, if you do it as you are seeing here, make sure you don't subtract the C from B. Yeah, most students are fond of doing that. I've been noticing that it is a problem to some of the students when adding fractions that are of that nature. You should understand what I meant by this statement. That are of that nature. I mean, that is A plus B minus C. They will add A and B, write the answer somewhere, and then later subtract C from B and add whatever they are going to get to the addition of what? A and B, which at the end of the day will make your answer wrong if you don't deal with it very carefully. So to avoid that, A and B, all of them are one thing. A plus B plus minus C. So it's either you subtract C from B and add A to the answer that you get, or you subtract C from A and add the answer that you get to B, or you add A and B and subtract C from it. Either any of these. Don't subtract C from B after adding A and B. I hope you are getting me. I've seen some of the students making that problem. Yeah, I've seen some of that. Is why I'm seriously talking about this one. I'm seriously hammering it. Yeah, it's very important. Most students, it does do. It's normal. Sometimes it's normal. It does confuse some of the students. I'm not saying it's normal. I'm not saying if you do that it means you are not. No, it's normal. Most of the times it does confuse some of the students. Okay, it does confuse them. Yeah. So just know that if you have something of that nature, just if you add to, make sure you subtract the other one from the answer that you get, not the other one from another either A or B, and then you add the answer, the two answers together. No, don't do it that. If you do it that way and you are not able to handle it very well, I'm saying it very well because it might be that the answer will be wrong. It might be that you'll be able to handle it to get the correct answer. So if you're not able to handle it very well, you get it wrong. Okay, so A plus B has given us what? This answer. Now we are going to subtract C from this answer. We will not subtract C from either A or B. Okay, so you're going to subtract C from what? This one. Yeah, we are going to subtract C from this one, but let's try and reduce it. You can maintain it and do the reduction when you are doing the subtraction aspect. Okay, you can also first reduce it to its simplest form before you subtract it from it. Okay, anyhow you do it, you're just going to get the same answer. Okay, so the other part, we are having 2 here and also we are having 2 here. We can factor out the 2. And this one is just at 110, so we use that 2 to reduce this 6, and that will give us what? 3. Okay, so 2 will cancel out with this 6 and it will give us what? 3. So then you're gonna get the whole of this over 3 tangent x multiplied by the whole of this. Good. So as you can see, the red A plus B is equal to this one in the simplest form. Now let's go ahead and subtract C from our answer. Adding this and then derivative of C together. I mean the answer we had to this one, the addition of this, the answer we had to this one, and then derivative of what? C. We are adding it together, but from the original question is minus. So though we are adding, but the operation sign there will tell. Okay. So that is, this one is in the bracket because we have already add A and then B, or the U over dx and then the K over ds. We have already added them. So this one means the answer to this one, and not this plus this minus this. No. Okay, good. This one we had the answer to be black. Black. So minus this was green. Yeah, guys, you see, I told you, when you know how to handle the cubes, it's not difficult to tackle the derivative of the answer to integral of what? Cube root of what? Tangent x. Just look at, here we are having what? Tangent x. 3 tangents. Look at this one, also having 3 tangents. So just master how to handle the cubes, and then there you'll be good to go. Okay, somebody may ask, oh, still it's not easy because this one is different from what is here. Yeah, though it's not that easy, but just look at this one, then look at this one. Right, just look at it. Though tackling them will not be all that easy, but just look at it. Yeah, just look at it. You see, what is here is the same thing as what is here. This one is different from what is here. Here is plus raised to the power 2 plus 1. Here is what? Raised to the power 2 plus 1, but it's minus. So we only need this this one. Yeah, we only need this one plus this minus sign to make this one equal to this. But it is not a problem. It is not a problem because we're going to find out at the end of the day. Okay? Good. 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 Alright, so this is what we are going to do. This is the same thing as this, which is very nice, but this is not the same thing as this, which is something else. The focus is on the denominator, not the numerator. But here, we cannot rewrite this one to look like this, neither can we rewrite this one to look like this. But still, it's not difficult. But still, it's not difficult. So this is what we are going to do. We are going to first find the LCM, or maybe we are going to multiply this one by this, and then minus this one times this one, all over this times this. With this part, though you will say it's difficult, but to me I will say it's not difficult. Yeah, I will say it's not difficult because I'll make you understand it. I'll make you understand it. Yeah, it's not difficult. It's not difficult. Don't put it in your head it's difficult. Just that it is confusing. You're just going to do some expansions and some others. That is the only thing that will be all getting us what confused. So that is why I'm saying I'll make you understand it. So it's not difficult. So if you put it in your head it's difficult, you'll not get it. You will not get it. So it is not difficult. Just say it yourself, it's not difficult. But it's not difficult. But don't tell me because I'm saying it's not difficult, it means it's difficult. It's not difficult. Because all that we are going to do is what we already know. When it is like this, multiply this by this, this by this, and then multiply this by this, and then you get your single fraction at the end of the day. Okay, so actually that is what we are going to do. That is what we are going to do, because there is no way we can make this to be equal to this, or we can make this one be the same thing as what this, though this one is the same thing as what this. Okay, good. Alright, so when we do it, as I said, this is what you are going to get. So here, this is what we are going to do. Remember, it's not difficult. It's not difficult. It just needs concentration. Here, let all your attention be here because you might get confused. That is why I said it's something else. You might get confused. Okay? Alright, let's look at something here. Here we have 3 tangent x multiply by this, multiply by that. Let's come here. We have 3 tangent x multiply by this. If you expand this bracket, is this times this plus this times this, right? Good. And also we are having this, but what is here is not the same thing as what is here. What is here is not the same thing as what what is here. So what are we going to do then, or what can we do then? Well, just look at this. Anytime any expression is being multiplied, just look at this bracket. Look at this bracket. And here is not difficult. It's not difficult, but just pay attention here. Just look at this bracket. Because of what I'm going to do. This times this plus this times this, it becomes something like this. So getting common thing here and then here will be difficult. Mind you, the whole of this times this is one thing. Same thing apply. The whole of this times this is one thing. It has become one thing because of the brackets and also because of how we have written this. When we expand it, we will still consider this one as one thing, also consider this one as one thing, because it is what? Multiplication. So here we will not expand this one. We will not expand it, but we will consider this. This here is affecting this one at the same time and also affecting the whole of this at the same time. So when we see this one here, it means it is here, here, at the same time here, here. Or when we expand this by this, we will just waste another time of multiplying this times this by the whole of this, which at the end of the day will be in this one and also will be in this one, plus this times this times this and then this. So at the end of the day, this will be in all of this and at the same time be in all of this. So which means 3 tangent x is common here. The same thing is applied here. When we waste time of expanding this one, it will be here at the same time here, 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 which in other case is also what? In all this, meaning 3 tangent x is common here with common reason of this and this being one thing. If it is a different thing, it has to be separated by what? An operation sign, as you are seeing here. So here, because this one is different from this, it is being separated by operation sign. That is what the minus here, or can be any other operation sign at all. That is plus. It has to be separated by plus or minus. Okay. So, but when it is one thing, it is being what? Made one thing by what? Multiplication. Yeah, let me put it that way. So the multiplication of this and this has made this one thing. So if I take anything from it, that thing that I have took away from this is already affecting all of this. So when you take it out, it has affected this and this already. I hope you are getting me. All that I'm trying to say here is that the common thing here is 3 tangent x. Here we are having 3 tangent x, which is in all this. When you come here to, oh shit. Forget it. Sorry guys. Let's continue. So here too, this one is in here and at the same time here, since it is what? One thing. So since this one is different from this one, we look at the common factor that is here at the same time here, which at the end of the day will come out and make the whole of this one after this one being taken out, and also the whole of this one after this one being taken out, as one thing. It becomes what? An expression where we can add or subtract. Are you getting the understanding? Yeah, don't confuse yourself with the first. Assume that the brackets are making it possible that the whole of this one and then this one is 1 thing. If you understand it to be like that, when you take this one out, it is not anything else. Okay, good. So now, since the whole of this one is 1 thing, we only compare 2 things to do the factorization, right? Yeah, when you are doing factorization, you compare 2 things to do the factorization. That is what is here at the same time what is here. So we will consider the whole of this one as 1 thing and the whole of this one as 1 thing. Therefore, factorization will be possible, right? Good. What is the common factor here? That is 3 tangent x. 3 tangent x. If you want to find out, don't really waste time of finding out. Just go ahead and do it as I'm doing it, okay? So here, we will just factor out 3 tangent x. And when we do that, it will be left with this one times this minus the whole of this one times this. That one also has become what? Another expression where we can add or what? Subtract some. Okay? What we have factored out is just going to reduce this denominator. Yeah, it's going to reduce it. If you don't reduce it and you go ahead and expand, at the end of the day, you will still end up reducing it. Other than that, you will not get your final answer. If you have any question, please let me know in the comment section, and then I will respond to you. Please make sure you leave your questions in the comment section for me, okay? Because this one is very simple. It's very simple. What is confusing us is understanding this and this as 1 thing. If you are able to get the understanding of or the concept of this and this being as 1 thing, factorizing 3 tangent x out is not anything else. Okay, good. Now let's factor out 3 tangent x. 3 tangent x. Okay, here, so then we are going to do cancellation, but let me clarify something here. You see, I said that the moment it comes out, everything becomes what? 1 thing, but just that we're just going to add or subtract some. Okay, just look at it. After bringing this one out, you see, we have gotten all of them to be in 1 bracket. That is the whole of this and then minus the whole of what? This. That's how it is. Okay, so when we expand it, you see, this one will affect the whole of this, at the same time affect the whole of this. Okay, all right. So here 3 tangent x will reduce this one, and we get this one to be also 3 tangent x. Here we're having 9 tangent x squared. 9 tangent x squared. Sorry, here 3 tan x times 3 tan x will give us 9 tangent x squared. Here is supposed to be tangent x squared. That is why you are seeing this tangent x squared here. Might be a mistake. The system didn't capture it. I entered it, but the system didn't capture. I don't know why. But here you see it has reflected. Yeah. So here it will give us what? 3 tangent x. 3 tangent x. Good. Now, here, just look at how lengthy the numerator is. Let's look at how lengthy the numerator is. Let's look at this. If we decide to, the only thing that we can do here is expansion. But it's not anything else, because when you expand, you see cancellation will be very, very, very simple. But if you don't expand, there's not any other thing that we can do. Okay, so this is what we are going to do. we are first going to work on the numerator alone, reduce it to its lowest term, and then work on the denominator alone, reduce it to its lowest term. After that, write as a single fraction and continue to look for a final answer. If you don't do it like that, you will not have enough space to work all of this out. Yeah, the reason why I'm doing it like that is just to get space to work all of this one out. And I think doing it like that will also help you get what the understanding. Okay, so let's look at it that way. First, let's look at the denominator. The numerator. So that is what the numerator. Now let me write the numerator for you. Alright, so this is what we are going to do here. We got no choice but to what? Expand. Here we got no choice but to what? Expand. Okay, so let's expand, and this is how we are going to do the expand. That is expansion of two binomials. That is this and then this. Bi means two. Bi means two. That is expansion of two binomials. So if you have that already, if you already have the understanding of that concept, just apply it here and then you are good to go. But what is going to be the problem is what? Is the cubes. That is why I'm always saying that if you know how to handle with the cubes, tackling it is not a problem at all, because differentiating, doing computation and blah blah blah, we all know how to deal with it. But the only new thing here is how to deal with the cubes, multiplying, rationalizing, adding, and other stuff. That's the only thing, and that only thing is the problem, because one problem can make an effort effortless. You should understand what I mean by that. The effort here is I'm trying all my best to, work on this one to get my answer. But because of how to rationalize cube, that one is making this effort that I'm trying effortless. Because no matter how much I try, I don't know how to deal with the cube. So all the effort I'm putting in, all the means I'm trying is becoming what? Useless. No use, because it will not work at the end of the day unless I get to know how to handle the cube. So one problem can make an effort effortless. Okay, so here is what we are going to do. We will first take this one, multiply by this, and then this, and later we will take this one, multiply by this, and then this, and then we look at if you can add or subtract some. After that, we also multiply this by this, and also by this, and by this. After that, we also look at common answers. That means those that can be added, those that can be subtracted, and those that can be all cancelled out. Yeah, some will be cancelled out and some will be all added and some will be all subtracted. Yeah, something like that. Okay, so let's move on. So this times this will give us what? Here the focus is on the cubes. This one, let's forget it. So when you multiply cube root of tangent x to the power 2 by secant squared times tangent x times cube root of what? Tangent x. Here we are having two cubes. Multiply by this with one cube. The answer is just very simple. It's just a matter of, because it is multiplication, remember it's what? One thing. So it's just a matter of I said let your focus be on the cube. if you get to know the cube and you're writing your answer, just write this one along because it's multiplication. Okay, so this times this one will give us what? Cube root of tangent x raised to the power 3, and that will cancel out the cube root sign. When it cancel out, you get tangent, and when you get tangent, already we have another tangent here. So tangent times tangent will give us tangent x squared. Okay, so secant x squared times tangent x squared times cube root of tangent x times cube root of tangent x to the power 2 is equal to secant x squared times tangent x squared. Why? Because this times this will make the power of 3, and that 3 will take away this cube root sign, and this tangent multiplied by this tangent will be 2. Okay, good. Plus this times this. Here secant x squared times cube root of tangent x to the power 2, and being multiplied by cube root of tangent x to the power 2. Focus is on the cube root. Okay, so this one times this one, they are the same. It does not mean it's going to cancel out. Here it only cancel out when it is equal to the 3, but here it's more than 3 because 2 times 2 give us what? 4, or 2 plus 2 give us what? 4. So when you multiply this by this, to give us what? Secant x squared times cube root of tangent x to the power 4, and that one is the same thing as, it's multiplication, so you can sometimes split. When you have 8, let's say when you have something like when you have 8, we can write 8 as 2 times 2 times 2. We can also write it as 2 raised to the power 2 times 2, or 4 times 2. You see, that's different ways of writing multiples of what? 8. 2 times 2, in terms of multiplication, 2 times 2 times 2 will give us what? 8. 2 times 2 raised to the power 2 times 2 will give us what? The same 8. It's because of what I'm going to tell you here. So when we multiply this by this, we are going to get secant x squared times cube root of tangent x to the power 4. And that one is the same thing as secant x squared times cube root of tangent x to the power 3 times cube root of what? Tangent x. And that 3 will cancel out with this 3, and we will get what? Tangent. So cube root of secant squared x times cube root of tangent x to the power 4 is the same thing as secant x squared times tangent x squared times cube root of what? Tangent x. Why? Because to the power 4 we can split it in terms of indices as cube root to the power 3 times cube root. Then you get the power to be 3 and then 1, which can be added to get what? The 4. So when 3 and then the cube root will just cancel out, and you get 1 tangent, and then you maintain the other cube root. Okay, but here I'm not going to do that. I'll just write to the power 4 for you. Okay, good. So now this one times this one will give us the same answer, times this one will give us what? The same answer. Okay, so when you expand this, you're gonna get secant x squared plus secant x squared times tangent x squared plus secant x squared times cube root of tangent x to the power 4 plus secant x squared tangent x times cube root of tangent x plus secant x squared cube root of 4 tangent x squared to the power 2. That is what we are going to get. And then when you come here, it's very simple. Just this by this, this by this, and then this by that, and you are done. Okay, so the focus is always on the cubes. It's always on the cubes. So this time this will give us what? Multiplication, right? So this is 4 and this is 2. So 4 plus 2 is what? 6. 6. So you get 6 over 2. 6 over 3, because the denominator, the value for what? The cube is what? 1 over 3. So it will be 1 over 3 times 6, and you get it 6 over 3, and that will give you 2. So the answer will be what? Tangent x squared. So here it will be secant x squared times tangent x squared. minus this times this one give us plus, to give us what? Plus. Or if you want, you can maintain it, put another bracket here, multiply. After that, you multiply the negative through. Anyhow, it's going to get the same answer. Okay, good. So we're gonna get plus, this one is 2, also this one is also 2, as we get for this part, like this and this. Okay, so you're gonna get the same thing as secant x squared times cube root of tangent x to the power 4. Okay, good. And then this times this will be what? The same thing as the, but what? Negative. All right. All right, good. So guys, what can you see here? That some are in different colors. Yeah, all those that are in different colors is representing those that are to be added or subtracted or cancelled out. Okay, good. I did that so that you know that this and this are the same, so it will be either added or subtracted. Okay, good. Now let's look at this one. What is here is the same thing as what is here. That is why they are in the same color. Okay, so this and then this will cancel out, because this is positive and then this one is what? Negative. So this will cancel out with what? This one. Okay, good. Now let's look at this one. This one is the same thing as this, right? So this will cancel out with this gone. What about those in blacks? Here we are having secant x squared times cube root of tangent x to the power 4 plus secant x squared tangent x times cube root of tangent x, and then here we are having plus this one, which is the same thing as what? This. Okay, so this, ideally this and then this is the same, so we can add. But what about this? Don't worry, you're gonna find out soon. So let's add. So this plus this one will give us what? 2 secant x squared times cube root of tangent x to the power 4 plus secant x squared tangent x cube root of what? Tangent x. But mind you guys, this one here is the same thing as this one here. This one here is the same thing as what? This one here. The reason why I didn't rewrite this one in this form or rewrite this one in this form is that when you expand it, you have to see what you have expanded. You have to see nothing else but what you have expanded. So when you expand it, this is what you will get. Okay, but in terms of adding, you have to apply your ideas of what about cubes, about how to handle cubes, in order to know that this and then this are the same. You know, when we try to expand this, remember I said that when we have 8 and we want to write it in the form of indices or maybe in the form of multiplication, it's the same as 2 times 2 times 2, which is 8. And also the same as 2 to the power 2 times 2. Is it not the same 8? Yes, it's the same 8. And you can also write it as 4 times 2, which is the same as what? The same 8. So in this case, cube root raised to the power 4 is the same as cube root raised to the power 3 times cube root. And we all know that when we get the power to be 3, it cancels out with what? The cube root sign, and we get what? Tangent. And when we get the tangent, the other one, because the power is less than 3, the sign will be what? Maintained. And at the end of the day, you get it to be what? Tangent times cube root of what? Tangent x. Okay, so when you are having it like this, you can change it to this form by assuming that or by applying this is that the power of this one is 1, and then the power of this one is what? 1 out of 3, right? The value of this one is 1 out of 3, okay? So that 1 out of 3, tangent times tangent, we add. So 1 plus 1 out of 3 will be what? 3 plus 1, 3 plus 1, right? 3 times 1 will be 3, plus 1 will be what? 4, which is 4 out of 3. It's not the same thing as this one when you will write it in terms of tangent, which will be the same thing as 4 over 3. So you see, but here we will rather split this one to look like this, okay? Good. So either way, either you treat this one in terms of tangent and then add the powers to get it to be in the form of this, and then you add all of them at the end of the day, or you expand this one further to look like this. So you expand this one further to look like this by writing this one as cube root of tangent x to the power 3 times cube root of what? Tangent x, all multiplied by this. So good, and that 3 will cancel out with this and you get this one. Okay, so it will be 2 times secant x squared times tangent x times cube root of what? Tangent x, plus this one, which at the end of the day they are the same. Okay, good. So you see, either this way or this way, anyhow you do it, you're going to get the same answer. We can also rewrite this one doing considering the powers, and that will give us to be, that will let this one be this, and at the end of the day we can add, and when we add it will be 3 secant x squared times cube root of tangent x to the power 4, or we expand this further and it will be in this form, and when we add we will get 3 secant x squared times tangent x times cube root of what? Tangent x. Okay, so let's add. All right, so that is what we are going to get. So guys, the answer to the numerator position after adding or doing the cancellation or after expanding, this is what we have gotten. As for this one, there is nothing that we can do to this one. There is nothing that we can do to this one unless we leave it as it is. Okay, we don't have to rationalize. There is nothing that we can do. Now let's move on to the denominator. Okay, so let me write the denominator for you. Here we are going to expand, but forget about this one. I said let your focus be on the cubes. The cubes is what is causing us not to try our hands on. So if you are working it, all our focus should be on the cubes. The cubes is the new thing here. Okay, good. So the same way as we did for the numerator's position, as we did for the how we work out the numerator, that is the same way that we are going to work out for the denominator. Okay, so this one multiplied by the whole of, it's actually the whole of this, but actually we will put this one aside and expand this one. After that we will multiply it by this. Okay, if you multiply this one through and then also multiply this one through and also multiply this one through, it will be something else. So first let's let our focus be on the cubes. Let our focus be on the cubes, expand it and know what we are going to get. After that we multiply this one through. Okay, so this times the whole of this, but we are going to take it one by one. So this by this will be what? The cube will be 6. So 6 will be 6 over 3, and that will be tangent x squared. Good. So this times this will give us what? I think that will give us cube root of tangent x to the power 4, but it's negative. Alright, and this time this will give us what? Just this one. Okay, so here we're gonna get tangent x squared minus cube root of tangent x to the power 4 plus cube root of tangent x to the power 2, and then plus, now 1 by this one will give us this, and so 1 by this one will give us minus this, and then 1 by this one will give us what? Plus this. All of them multiply by this. Okay. Good. Now let's see. This times this is giving us what? This tangent s squared. And then this times this giving us what? The minus to the power 4. And then this times this will give us what? The plus 1 here. Okay. Plus this one. That is the plus here. So 1 by this is this 1. Yeah. And also 1 by this is this minus 1 here. This times this is just the positive 1 here. Now what and what are the same? Minus cube root of tangent to the power 4 is the same thing as the positive 1 here. So this will cancel out with this one. Yeah, this one didn't get it to be like that. It doesn't matter. This one is not lengthy and it's not it's not lengthy, so this one you can easily see it. So this cancel out with this, and then this cancel out with this, and to be left with what? 1. So actually it's going to give us what? Tangent s squared. Then we multiply it by this. Tangent x squared. Tangent x squared. So here there is nothing that we can do but to bring in the identity of what? This one. That is trig identity. 1 plus tangent s squared is equal to secant s squared. Secant s squared. So here tangent s squared plus 1 is equal to what? Secant x squared. Secant x squared. Alright, so after expanding the denominator, that is what we have gotten. That is what we have gotten. Now we know the simplest form for the numerator. We also know the simplest form for the denominator. So now let's write our fraction back and see what we are going to get at the end of the day. Guys, I hope you are still enjoying this video. You see how the methods we are using to work out the solution is making the problem very exciting, very entertaining, because if that is how math is, if you don't look at it bit by bit and you just combine them, all of them at the same time, if you are not good enough, it will be something else. But if you look at the way we are working out the solution, it is making it very entertaining. You know, that lengthy thing, look at this one, look at this whole thing, look at what we have gotten from it. Just simple thing. You see, the cubes is something, but if you know how to handle it, it's not anything else. Alright? Yeah, sure. But please don't forget to hit the subscribe button for more. Okay? Good. Now let's move on. Alright, for the numerator, this is what we had for the numerator aspect. Remember, this one is the same thing as what? Secant s squared times cube root of tangent s to the power 4, or this form. And then denominator, this is what we have gotten. So guys, what are you seeing at the end of the day? No, I don't want to complete it. You can pause it and complete it yourself. Are you seeing what I said you'll be seeing? Are you getting it? So guys, are you seeing it? So you see, if you got to know how to handle the cubes, it is not anything to tackle. It's just a very simple thing to do. But as I said, one problem can make an effort and effortless. But the same thing, one solution can make an effort or effective effort. Why? Because if you know solution to a particular problem, it can make the effort that you are applying to be what? Effective, or to be what? Yeah, to be what? Effective, because maybe that problem was something which was impeding you from doing whatever you are good. Now that you have gotten the solution, you already know how to tackle the rest. So the solution that you have gotten is just, boosting your morale, just going to help you work more faster, than, because what was impeding you is now solved. So you have nothing to worry about. So if you are moving on, you say you are moving on, there will be no stoppages. Okay, So you see, the lengthy calculations, rationalize, do this, blah 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 blah. See what we have gotten at the end of the day. Just look at it. By just looking at it, the answer itself is what? Coming. It has already appeared. By just looking at it, the cancellation is very simple. Everybody at all can do these cancellations to get the final answer, because the cancellation is very clear, very clear. You see, it's very simple. Yeah. So what are you gonna do? This cancel out with this cancel out with this cancel out with this. What is left? That is the cube root of what? Tangent x, which is exactly what we integrated in our previous video. What do you guys think? Yeah, really cool, pretty good. Yeah, very exciting. You know, when you get your answers like this, you just become so excited that you don't even know what to do, right? But during the workings, I believe that most of you will be, bored. You will be thinking in their head, look at all that we are going to do. This one, I don't think we are going to get the answer. Because let's look at this, what we are doing. The cube, do this. Very confusing. Yeah, but all that we did, look at what we have gotten at the end of the day. You have managed to get our answer at the end of the day. Remember, whatever you integrated, when you differentiate it, you should get it back. No matter what, you should get it back. If you don't get it back, it means the answer you had is totally wrong. Okay, so guys, this cancel out with this, and what is left? The cube root of tangent x. That is it. Yeah. So the derivative of what we started, the a, b, and c, is cube root of what? Tangent x. Very nice. Yeah, very nice. So what do you guys think? What do you guys think? Yeah, very nice. Yeah. Bye. Let me know what you think in the comment section. But also, on a more serious note, on each of the workings that we did, if you having any question on any of them, if you are lacking any understanding on any of them, please kindly let me know. Either you do it through my email, or maybe you will leave it in the comment section, and I'll make sure I respond to you. Okay. And also, if you have any question, you have any problem concerning what we just did, or maybe other problem, you can also reach out either through my email or in the comment section, and also respond to you. Okay. That's very cool. That's nice. All right, that's it for you guys. All right, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching, and I will see you in another video. Bye.